This video will be on the exponential laws and just a few examples where we apply them. So just as a revision, if we are to look at what is an exponent, so just to familiarize you or refresh your memory with what the terminology is, when we see this, x is what we call the base, okay? And then up here, m is what we call the exponent or the power. Sometimes you'll see the word index being used, but we won't be using the word index, so we can use exponent or power. And an important thing to remember is that the power applies to what it touches. So to help you understand what we mean by that, when you see this, this 4 is only touching the x, okay? The 2 is what we call a coefficient. So this is actually the coefficient. It does not get the power. The x is the base here. And of course, 4 is your power. Now, in this case, most students probably, you might have been like, well, obviously the 2 is not getting the power. But where we generally see a mistake is when we give you something like this. So here, remember in math, we have what's called our invisible ones. So in front of this x is a negative, which means we're multiplying it by -1. So this is the base. Compared to, so versus, if I gave it to you like this. Now the entire thing, including that negative, is part of my base. And that's what the brackets do. They encapsulate that negative x so that that would be the base, okay? So that's important to remember. So in the first part over here, that negative is not affected by the power. Whereas in the second part, where I've got the brackets, then the negative is affected by the power. So now we're just going to go over the exponential rules. So we have the product rule. So in mathematics, we remember product means to multiply. And the rule, if we are to write it out, and the rule only applies when we have same base multiplication. What we do, so if then, so almost like a coding statement, we write down the base and we add the exponents. So to give this rule, to write it out in a general form without using words, so here my base is a, and I'm multiplying by another base a, and so the rule says write down the base and add the exponents, okay? Then we have the quotient rule, and the order of the rules don't matter. So it's not like there's rule 1, rule 2. So quotient rule, and remember the quotient is found when we are dividing. So if you have same base division, you write down the base and then you subtract the exponents. Now in this case, I'm going to show you what we should be doing, because when we have any exponent questions where they say simplify, we always want the answer expressed with positive exponents. So the way we write out this rule is we actually kind of add a middle step where we first look to see where my power is greater. So if the power is greater at the top, so that would mean that m is greater than n, then we will write down the base at the top. And then we will say m minus n. I'm actually going to keep that in black like we've been doing. And then if we had n, meaning the exponent is greater at the bottom, so n greater than m, then we would write 1 over, so that we can put the base at the bottom, n minus m. And that way we would get a situation where we have positive exponents. The next rule we have is the power rule. And here is the rule in words. If you raise a power to a power, we write the base and we multiply the exponents. So to visualize this, if we had a to the power m, and then we're raising it to another power, then we would have mn. Remember, in mathematics, when you write the two variables next to each other, it means we are multiplying them. So the next two rules, we don't really verbalize or write out the rule itself. We just kind of illustrate them. So So power of a product. Power of a product, the way we see this is, remember, product means we are multiplying. So if I give you two things that are being multiplied inside the bracket and I raise the whole thing to a power, then everything gets the power. Okay, notice it's not power of addition, it's only power of a product. And then we have power of a quotient. And remember, quotient is when we are dividing. So here again, if I am dividing, which is the same thing as just seeing a fraction, okay? Because remember that fraction line means division, and I raise that to a power, then everything gets the power. Now, these were the rules. There are also what we call identities, or I guess sometimes we can also call them rules, but basically there are properties. So here we're going to talk about negative exponents. So negative exponents, if we have a whole number or a whole number base that has a negative exponent, then we can change that and make that a positive exponent by just putting that number into the denominator. So we flip it. So this would have been like a over 1. It becomes 1 over. Okay. Likewise, if it was negative in the denominator, then we bring it up to the numerator. And remember, we don't write over 1. Okay. If it was an actual fraction, so we had two components, numerator and denominator, and then we have a negative exponent, then we just flip the fraction, and now it has a positive exponent. Another identity is the zero power identity. And what this means, or what this identity is that anything to the power 0 equals 1. So basically, if I have any base, it doesn't matter what it is, and I raise it to the power 0, then I will have 1. Okay, so take down these notes and make sure that you have them to refer to, because the next two videos we're going to do is where we're going to actually use all these rules, okay?